Hello everyone. This video is the second part of the projectile motion example. And last video we have already solved out the initial velocity of the object, and you need this minimum velocity to pass the barrier. Okay, and the answer is 11.13. Oh, let me see. 11.13. Which color I should use? Okay. V is equal 11.13 meter per second. And the second problem is you want to calculate how far the object will reach. Okay, that means you want to know this distance. Okay, this distance, how far it will reach. And for this problem, once again, we just use the equation of motion. Okay, so he want to find out the distance here. That means he want us to find the final coordinate of this object of the x component. Okay, because we set the origin here. This is the origin. Okay, is the x. Here is y. Oh, sorry, not very straight, but you understand. You don't understand. Okay, what's the xf? Because this relates to the final the distance you reach. Okay. So we just write down all information we have. Xf. Okay. Let's just assume we add when the object reach here is t prime. At t prime, the object reach here. Okay, so the first one, xf, we don't know, so set it, we don't know. Initial position of objects, 0. And initial velocity x component is 11.13 times cosine 35 degree. And time t prime. And x direction, there's no acceleration, so just don't ignore it. So from this, we want to calculate xf, but the t prime we don't know. So we need information on t prime. So we have to use another equation on the y direction. So the y direction, okay, y component, the equation of motion of y component. So equation of motion y component, what's the position of what's the y coordinate of the object at the final state? This is the final state here. Okay, and what's the y component of final state? It's also 1.6. It's also 1.6 because we set the origin here, and this is 1.6. Okay, so 1.6. And the initial position here, 0. And initial velocity and the y component is 11.13 times sine 35 degree and times t prime. Okay, t prime we don't know. And the acceleration is y direction. In last video I said be careful, so it's minus 4.9 t squared because it's 9.8 put downward, so it's negative 9.8 and time and divided by 2, so it's minus 4.9 t squared. Sorry, I should write t prime square. T prime square. From the second equation, we can solve t prime. Okay, because in this equation, you see we only have one unknown. The other we all know. 30 sine 35 degree we know. Other number we all know. So we will get the equation like this: 4.9 t prime square. Then be careful we have to move everything to the left, so we need to be careful. So let me check. Yeah, you can compute by yourself. Don't waste everyone's time to do the calculation here. You go 0. Okay, so we will obtain a quadratic equation. For solving a quadratic equation, I believe all of you can solve the quadratic equation. So the t prime, we got two solutions. One is 0.34, the other is 0.96. Okay, well, why do we have two solutions? Okay, it's not easy to understand. Okay, which one is our answer? The answer is this one. Okay, the answer is one, the bigger one. Okay, the smaller one, 0.34, because when you look at the graph, this point, the y component is also 1.6. Here is also 1.6. That's why we have two solutions. One is 0.0 t equals 0.34 is for here, and here is for 0.96. So this is the answer we want. Okay, because that's we want to find a point because fly longer. Okay, this is a shorter time, longer time is reach here, and we want to calculate distance here. So that means we need t. We need this bigger t prime. Okay, so when we put the 0.96 into this equation. So I think you will get the answer xf is equal to, you can go by yourself. I think it's 8.75. So 8.75 is this range is 8.75. 8.75. But if the question want to ask this range, this is just minus 3.1, just 5.65. Okay, so once again we just use equation motion, we can solve everything. Okay, that's the example for 2D motion, 2D and projectile motion. I think it's we I think that's just all, just so simple. Just use the equation of motion. Keep doing equation of motion. Try to figure out your initial setup and try to figure out how many unknown you have. If you don't have information in one equation, just find another one. Okay, you'll finally get your answer. Okay, so this is pretty much about the video, and see you in the next video. Okay, bye bye.